CISSP. Certified Information Systems Security Professional. Domain 3, Security Architecture and Engineering. Security architecture is the design to reduce the security risks associated with a system to an acceptable level. Security engineering is the implementation of security architecture design. Processes using secure design principles. A principle is defined as a general or fundamental truth. Secure design principles are the fundamental truth upon which systems are built in order to be resilient against attack. Secure design principles reduces vulnerability and mitigates risk. Saltzer and Schroeder's design principles are design principles by Jerome Saltzer and Michael Schroeder in their 1975 article The Protection of Information in Computer Systems. Saltzer and Schroeder's principles are economy of mechanism, fail-safe defaults, complete mediation, open design, separation of privilege, least common mechanism, psychological acceptability, work factor, and compromise recording. Economy of mechanism. Keep the design as simple and small as possible. Fail-safe defaults. Fail-safe states that the system should reconfigure itself to default or no access and avoid the failed components affects the normal functionality. Complete mediation. Every access to every object must be checked every time. Open design. Design should not be secret. Separation of privilege. Separation of privilege. Separate users and processes based on different levels of trust, needs, and privilege requirements. Least privilege. Least privilege is giving a subject or process only the privileges it needs to complete a task. Least common mechanism. Minimize sharing components between users, especially when the component must be used by all users. Psychological acceptability. It is essential that the human interface be designed for ease of use, so that users routinely and automatically apply the protection mechanisms correctly. Work factor. Work factor is the degree of effort required to compromise the security control. Compromise recording. Record compromise of information can be used in place of more elaborate mechanisms that completely prevent loss. ISO/IEC 19249. In 2017, the International Organization for Standardization, ISO, published its first revision of Standard 19249, Information Technology Security Techniques Catalog of Architectural and Design Principles for Secure Products, Systems, and Applications. ISO 19249 is to describe architectural and design principles to be used to develop the secure development of systems and applications. ISO/IEC 19249 Architectural Principles. 5 Architectural Principles from ISO/IEC 19249 are: Domain separation, layering, encapsulation, redundancy, virtualization. Domain separation. Domain separation: separate data, processes, and administrative tasks. Layering. Layering separates hardware and software functionality into modular tiers. Encapsulation. Encapsulation takes information from a higher layer and adds a header to it, treating the higher layer information as data. Redundancy. Redundancy, providing multiple instances of either a physical or logical component such that a second component is available if the first fails. Virtualization. Virtualization adds a software layer between an operating system and the underlying computer hardware. ISO/IEC 19249 Design Principles. 5 Design Principles from ISO/IEC 19249 are: Least privilege, attack surface minimization, centralized parameter validation, centralized general security services, preparing for error and exception handling. Least privilege. Least privilege is giving a subject or process only the privileges it needs to complete a task. Attack surface minimization. Attack surface minimization is to reduce the overall risk by reducing the attack surface area. Centralized parameter validation. Ensuring that parameters are valid is common across all components that process similar types of parameters. Centralized general security services. The principle of centralizing security services can be implemented at several levels. At the operating system level, your access control, user authentication and authorization, logging, and key management are all examples of discrete security services that can and should be managed centrally. Preparing for error and exception handling. Systems must ensure that errors are detected and appropriate action taken. Defense in depth. By using combinations of security controls, the impact from the failure of any single control can be reduced if not eliminated. In 1972 by James Anderson in Computer Security Technology Planning Study. Security functions need to be implemented in a manner that prevents their being bypassed, circumvented, or tampered with. Security functions need to be invoked whenever necessary to implement the security control. Security functions need to be as small as possible so that defects are more likely to be found. Fundamental concepts of security models. A model is a simplified representation of a system to understanding of the real system. A security model is a model that deals with security policy. Security models provide rules of the road for securely operating systems. Security models help understand complex security mechanisms in information systems. Finite state machines. A finite state machine is a mathematical model. A finite state machine is specified by a finite set of conditions of existence called states. State transition function determines next state and produce output. Lattice security model. A lattice is a finite set with a partial ordering. A partial ordering is reflexive, antisymmetric, and transitive. Reflexive means that each item in the set is equal to itself. A greater than or equal to a. Antisymmetric means that if A greater than or equal to B and B greater than or equal to A, then A equals B. Transitive means that if A greater than or equal to B and B greater than or equal to C, then A greater than or equal to C. Bell-LaPadula model. Bell-LaPadula model was originally developed for the U.S. Department of Defense. It is focused on maintaining confidentiality. Bell-LaPadula model has 3 rules. Simple security property. Star property. Strong star property rule. Department of Defense. Classifies information based on sensitivity at 3 basic levels: confidential, secret, and top secret. The simple security rule: no read up. A person in one classification level cannot read data in a higher classification level. If you have a secret clearance, then you cannot read objects with a label of top secret. The star property rule: no write down. A person in a higher classification level cannot write messages to someone in a lower classification level. If you have a clearance of top secret, then you cannot write messages to someone with a secret clearance. The strong star property rule: a person in one classification level cannot read or write intelligence to any other classification level. If you have a clearance of secret, then you are only allowed to read and write data to objects with the same classification label. The BIBA Integrity Model. To address the integrity issue, Kenneth Biba developed BIBA Integrity Model. BIBA Integrity Model has 3 rules. Integrity Axiom. Simple Integrity Axiom. Invocation Property. Integrity Axiom: no write up. A subject cannot write to a higher integrity level than that to which he has access. Simple Integrity Axiom: no read down. A subject cannot read to a lower integrity level than that to which he has access. Invocation Property: a subject cannot invoke, request service, of higher integrity. Clark-Wilson Model. Clark-Wilson Integrity Model. Developed after the BIBA model, this model also concerns itself with data integrity. Clark-Wilson Integrity Model. Elements are user, transformation procedure, TP, constrained data item, CDI, unconstrained data item, UDI, and integrity verification procedure, IVP. User, an active user's agent. Transformation procedure, TP, an abstract operation, such as read, write, and modify, implemented through programming. Constrained data item, CDI, an item that can only be manipulated through a TP. Unconstrained data item, UDI, an item that can be manipulated by a user via read and write operations. Integrity verification procedure, IVP, a check of the consistency of data with the real world. Clark-Wilson Integrity Model also sets well-formed transactions. Separation of duties. Separation of duties: this concept ensures that certain operations require additional verification. Well-formed transaction ensures that all values are checked before and after the transaction by carrying out particular operations to complete the change of data from one state to another. The Brewer-Nash Model. Brewer-Nash or Chinese wall model is designed to avoid conflicts of interest by prohibiting one person, such as a consultant, from accessing multiple competitors' data. It was initially designed to address the risks inherent with consultants working within banking and financial institutions. Conflicts of interest pertain to accessing company-sensitive information from different companies that are in direct competition with one another. Chinese wall model requires that conflict of interest categories be identified so that once a consultant gains access to one company, they cannot read or write to an opposing competitor's company. Select controls based upon systems. Security requirements. A requirement is a specification of a need or want. Requirements are used to capture the information needed to design, build, and test. A security requirement is a business need related to the protection of an organization. A security control is a way to fulfill one or more security requirements. Selecting security controls starts with an analysis of the security requirements. Security requirements are determined by Analysis of regulatory or compliance requirements. An analysis of the threats the system. A risk assessment of the system. Organization that processes account numbers and handles bank card transactions. Their systems must be PCI DSS compliant. Security framework are ISO 27001, NIST SP 800. 37 Risk Management Framework, National Institute of Standards and Technology. NIST, Cybersecurity Framework, CSF, COBIT 5. Frameworks are not mandatory. Frameworks are not mutually exclusive. Frameworks can be specialized in either an industry or scope. NIST Cybersecurity Framework is widely recognized general security framework that is applicable for basically any industry. Health Information Trust. Alliance Cybersecurity Framework is a comprehensive security framework for the healthcare industry. Security frameworks are not the same as a standard or a control list. Security framework is an approach or strategy. Security framework will provide guidance. Standard is a set of quantifiable directions or rules to follow. NIST Special Publication 800-37, Risk Management Framework, breaks down the task of securing a system, starts with categorizing the system, identifying the proper security controls, implementing those controls, assessing their impact, and then authorize and monitoring the system. Threat modeling and risk assessment provide information on which controls are most important and need to be implemented. Plan phase, consider the control and how to implement and adapt it to your specific circumstances. Do phase, implement the control. Check phase, assess the effectiveness of the control. Act phase, remediate the gaps and deficiencies. Security capabilities of information systems. And information systems are the combination of people, information technology, hardware and software, and business processes to accomplish a business objective. Technical information security controls are based on the hardware security capabilities. Hardware security basic concepts are memory protection, virtualization, trusted platform modules, TPM, cryptographic modules, hardware security modules, HSM, smart cards. Memory protection. Memory protection. Permit programs with different levels of security access to run at the same time. Memory protection enables the operating system to load multiple programs into main memory at the same time and prevent one program from referencing memory not specifically assigned to it. If a program attempts to reference a memory address it is not permitted to access, the system blocks the access, suspends the program, and transfers control to the operating system. Dual mode operation means the processor can operate in one of, at least, two modes: privileged, or kernel, mode, and unprivileged, or user, mode. Privileged mode, or kernel mode, provides unrestricted access to all resources in the machine. This is the mode in which the kernel runs. User mode gives applications access to a restricted subset of the machine in order to protect the OS from applications. An application can only access memory that the OS has made available to it and should not be able to uncontrollably interfere with or bypass the OS directly. Once a program has been loaded into memory, the operating system transfers control to the program and simultaneously transitions to unprivileged mode. Virtualization. Virtualization is the ability to run multiple operating systems on a single physical system and share the underlying hardware resources. Secure crypto processor. The term crypto is becoming popularized by Bitcoin and discussions of cryptocurrency. A secure crypto processor is a dedicated computer on a chip or microprocessor for carrying out cryptographic operations, embedded in a packaging with multiple physical security measures, which give it a degree of tamper resistance. Types of secure crypto processor are proprietary, open standard, standalone, smart cards, trusted platform module, TPM. A trusted platform module is a microchip that is often built into a computer to provide hardware-based security. Cryptographic module. Cryptographic module is hardware or software or component that implements key generation and other cryptographic functions and is embedded in a larger system. Hardware security module, HSM. A hardware security module, HSM, is a dedicated crypto processor that is specifically designed for the protection of the crypto key life cycle. Smart card. Smart cards are credit card-sized cryptographic modules typically used to provide portable secure storage for the purposes of identity management, secure transport of sensitive information and payment processing. Assess and mitigate the vulnerabilities of security architectures, designs, and solution elements. Architecture is the art and science of designing buildings and other physical structures. Computer architecture is the underlying structure of the computer system. Security architecture is the process of making an architecture more secure. Vulnerability is a weakness which can be exploited. IT components, such as operating systems, application software, and networks have many vulnerabilities. These vulnerabilities are open to compromise or exploitation. We will discuss, assess and mitigate the vulnerabilities of security architectures are client-based systems, server-based systems, database systems, cryptographic systems, industrial control systems, ICS, cloud-based systems, distributed systems, and Internet of Things, IoT. Client-based systems. Sensitive data left behind in the file system. Temporary files and cache files may be accessible by other users and processes on the system. Unprotected local data may have loose permissions and lack encryption. Vulnerable applets. Browsers and other client applications employ applets for viewing documents and video files. Often, the applets themselves may have exploitable weaknesses. Unprotected or weakly protected communications. Data transmitted between client and other systems may use weak encryption, or use no encryption at all. Weak or non-existent authentication. Authentication methods on the client or between the client and server systems may be unnecessarily weak. Server-based systems. Sensitive data left behind in the file system. Unprotected local data. Unprotected or weakly protected communications. Data transmitted between the server and clients may use weak or use no encryption. Weak or non-existent authentication. Authentication methods on the server may be unnecessarily weak. Database systems. Deployment failures. Broken databases. Data leaks. Stolen database backups. The abuse of database features. A lack of segregation. SQL injections. Substandard key management. Database inconsistencies. Default or weak username/passwords. Cryptographic systems. Use of outdated algorithm. Use of untested algorithm. Failure to encrypt encryption keys. Weak cryptographic keys. Insufficient protection of cryptographic keys. Industrial Control Systems, ICS. Loose access permissions in the industrial control systems. Failure to change default access credentials in the industrial control systems. Access from personally owned devices in the industrial control systems. Lack of malware control in the industrial control systems. Failure to air gap in the industrial control systems. Organizations fail to air gap, isolate, the industrial control systems ICS from the rest of its corporate network. Failure to update industrial control systems components. Cloud-based systems. Cloud computing services are categorized into three types: Software as a Service, SaaS. Platform as a Service, PaaS. Infrastructure as a Service, IaaS. Software as a Service, SaaS customers are provided access to an application running on a cloud infrastructure. Application is accessible from various client devices, but customer does not manage underlying cloud infrastructure. SaaS models place the most responsibility on the cloud service provider. Cloud service provider on the SaaS model securing applications and data, runtime and middleware, servers, virtualization and operating systems, storage and networking, physical data center. Platform as a Service, PaaS customers can deploy supported applications onto the provider's cloud infrastructure, but customer does not manage the underlying cloud infrastructure. Customer has control over the deployed applications and limited configuration settings for the application hosting environment. Infrastructure as a Service, IaaS customers can provision processing storage, networks, and other computing resources and deploy and run operating systems and applications, but the customer does not manage underlying cloud infrastructure. Customer has control over operating systems, storage, and deployed applications as well as some networking components. Cloud deployment models are public, private, hybrid, community. Public cloud refers to the cloud computing model with which the IT services are delivered across the Internet, such as Amazon Web Service or Microsoft's Azure. Private cloud is the cloud solution dedicated for use by a single organization. Hybrid cloud is the cloud infrastructure environment that is a mix of public and private cloud. Community cloud is a group of organizations from the business community that share the same common content such as compliance, security, and so on. Distributed systems. A distributed system is an environment where multiple computers are working together to perform tasks. Examples of distributed systems are cellular network, peer-to-peer network, distributed database management systems, aircraft control system, multiplayer online games. Loose access permissions is vulnerability in the distributed systems. Unprotected or weakly protected communications is vulnerability in the distributed systems. Weak security inheritance is vulnerability in the distributed systems. Lack of centralized security control is vulnerability in the distributed systems. Critical paths is vulnerability in the distributed systems. Internet of Things, IoT. Internet of Things (IoT) is the concept of connecting any device to the Internet and to other connected devices. Top 10 IoT OWASP Vulnerabilities, 2018. Weak, guessable, or hard-coded passwords. Insecure network services. Insecure ecosystem interfaces. Lack of secure update mechanism. Use of insecure or outdated components. Insufficient privacy protection. Insecure data transfer and storage. Lack of device management. Insecure default settings. Lack of physical hardening. Assess and mitigate the vulnerabilities in web-based systems. A web-based system provides access to a software system using a computer and internet connection. Web-based applications are installed and run on a remote server access with web browser. Web browsers are installed on computer and allow to access websites. Web browsers are Google Chrome, Firefox, Microsoft Edge Opera, and others. Open Web Application Security Project, or OWASP, is an international non-profit organization dedicated to web application security. OWASP Top 10 Application Security Risks are: injection, broken authentication, sensitive data exposure, XML external entities, XEE, broken access control, security misconfiguration, cross-site scripting, using components with known vulnerabilities, insufficient logging and monitoring, cross-site request forgery. Injection vulnerabilities. Injection vulnerabilities are flaws that allow attackers to inject malicious code in another system using an application. When an application accepts user inputs and allows these inputs to enter a database, shell command, or operating system, making application susceptible to an injection flaw. These flaws are result of insufficient input validation. Common types of injection flaws are SQL injection, command injection, LDAP injection, XPath injection, and XML injection. SQL injection, where attackers insert malicious SQL code into a SQL database to provide unauthorized access to private data. Command injection is an attack in which the goal is execution of arbitrary commands on the host operating system via a vulnerable application. LDAP injection is an attack used to exploit web-based applications that construct LDAP statements based on user input. Similar to SQL injection, XPath injection attacks occur when a website uses user-supplied information to construct an XPath query for XML data. XML injection is an attack technique used to manipulate or compromise the logic of an XML application or service. Broken authentication. Broken authentication is the breach in the authentication procedure of a web application. Broken authentication vulnerabilities are plaintext passwords in transit, plaintext passwords at rest, weak passwords, single-factor authentication, password guessing, man-in-the-browser attack, and session hijacking. Plaintext passwords in transit transmits a clear text password via an HTTP connection, then user's password will be communicated in plaintext and at risk from eavesdropping. Plaintext passwords at rest means that anyone who looked through the database would be able to just read the user's passwords. Weak password is a password that is easy to detect both by humans and by computer. Single-factor authentication is a process for securing access to a system, identifies requesting access through only one category of credentials. Password guessing is the process of attempting to gain access to a system through the systematic guessing of passwords. Password guessing can be prevented by using a CAPTCHA. Password guessing can be prevented by delaying subsequent login attempts after each failure. Password guessing can be prevented by locking out the account completely. Man in the browser, MITB, attack utilizes a Trojan horse in a pre-infected device/system to infect the internet browser, and sniff, capture and modify information as it travels between the user interface of the infected browser and the internet. Man in the browser attack can be mitigated to do not install browser extensions or add-ons from untrusted sources. Man in the browser attack can be mitigated to keep your operating system and browser up to date. Man in the browser attack can be mitigated to install and update anti-malware. Session hijacking refers to an attacker's ability to take over a portion of a session and act as one of the participants. As users interact with a web application needs to keep track of which requests came from which users. Session tokens are used to connect disparate HTTPS requests to a single user. Session tokens can be compromised by guessing and brute force. Guessing: secure session tokens must be generated by a cryptographically secure pseudo-random number generator. Brute force: secure session tokens must be long enough, at least 128 bits. Session tokens must also be invalidated when the user successfully logs in and logged off. Sensitive data exposure occurs when an application or program does not adequately protect information such as passwords, payment info, or health data. Sensitive data exposure vulnerability. Transmission of sensitive data in the clear. Lack of appropriate HTTP security headers used to mitigate the possibility of man-in-the-middle attacks. Incorrectly configured HTTP headers. Weak ciphers. Storing user passwords in plaintext. Extensible Markup Language, XML, is a standard, platform-independent markup language that defines format rules for encoding data. An attacker could abuse XML features to carry out denial of service attacks, access logical files, generate network connections to other machines, or circumvent firewalls. XML mitigation techniques. Using a less complex file format. Ensuring XML parser library is current. Properly configure XML parser and disable security-sensitive options. Using positive server-side sanitization to validate input and prevent malicious code. Application firewall monitor for XXE attacks. Broken access control occurs when a server does not properly validate every request. Server validates users' access to an admin page, but does not validate the post or get from that page. An attacker with knowledge of the post or get URL bypassing the validation. An attacker who tampers parameters can bypass validation. Always check the identity and authority of user to perform the requested operation on every request. Security misconfiguration can happen at web application, network services, platform, web server, application server, database, frameworks, custom code, pre-installed virtual machines, containers, or storage. Preventing security misconfigurations. Default accounts must be disabled. Unnecessary features and services must be disabled. Error reports must be logged. Security headers must be enabled and properly configured. Cross-site scripting, XSS, is an exploit where the attacker attaches code onto a legitimate website that will execute when the victim loads the website. Cross-site scripting, XSS, attacks can generally be categorized into two categories, stored and reflected. Stored attacks are injected script is permanently stored on the target servers, such as in a database, in a message forum, visitor log, comment field, etc. Reflected attack victim clicking on a carefully crafted link, for example in an email or another website, that sends the attacker's malicious script to the target website. The mitigation is to never trust user input. Using components with known vulnerabilities. Keeping an accurate inventory of all the components of web application is important. Automated vulnerability management tools to scan web application and detected packages against a database of known vulnerabilities. Exploitation of insufficient logging and monitoring is the bedrock of nearly every major incident. Logging must capture all relevant events. Logging must record details. Logging must be centralized. Logging must be immutable. Monitoring should alert when limits are exceeded. Cross-site request forgery, CSRF, is an attack that forces an end user to execute unwanted actions on a web application in which they're currently authenticated. Cross-site request forgery, CSRF, attacks specifically target state-changing requests, like transferring funds, changing their email address, not theft of data. Cross-site request forgery, CSRF, token is a unique random value that is prevent cross-site request forgery attacks. Assess and mitigate vulnerabilities in mobile systems. Today almost everyone has a mobile device. Mobile systems are the operating systems and applications on smartphones, tablets, phones, smartwatches, and wearable device. The most popular operating system platforms for mobile systems are Apple iOS and Android. Mobile system security vulnerabilities are weak or missing passwords, pins, lack of multi-factor authentication, long session lifetime, wireless vulnerabilities, mobile malware, lack of security software, unpatched operating system or browser, lack of inherent firewall, and insecure devices. Passwords. A strong password and PIN would be a great on mobile system security. For example, a PIN for device login, then a password for application login. Multi-factor authentication. Multi-factor authentication provides layered security by requiring users to prove their identities using two or more verification methods before they can be authenticated. Session lifetime. Long session lifetime allows an attacker to use existing session identifier to log into the application. Wireless vulnerabilities. Wireless networks are particularly vulnerable to attacks because it is difficult to prevent physical access to them. Mobile malware. Mobile malware is malicious software specifically written to attack mobile devices such as smartphones, tablets, and smartwatches. Unpatched operating system or browser. Users not updating their devices. Phones that are no longer supported and no longer receiving security updates. Mobile device manufacturers delay updates. Insecure devices. Jailbreaking is obtaining administrative rights on an iOS device. Rooting is obtaining administrative rights on an Android device. Jailbreaking or rooting significantly reduces the inherent security of the device. Mobile device management. Mobile device management is software that allows to control, secure, and enforce policies on smartphones, tablets and other endpoints. Mobile device management security features are jailbreak detection, vulnerability management, remote lock, remote wipe, device location, data encryption, sandboxing, anti-malware, VPN and containerization. Assess and mitigate vulnerabilities in embedded devices. Embedded means hidden inside. An embedded system is a microcontroller or microprocessor-based system which is designed to perform a specific task. Examples of embedded systems are automated teller machine, ATM, washing machine, vending machines, Wi-Fi routers, medical instruments in hospitals, and smartphone. Embedded system attack surfaces vulnerabilities are user interface, physical attacks, sensor attacks, output attacks, and processor attacks. User interface attacks are manipulating controls of the device in a manner that causes the device to not work properly. Physical attacks are directly compromise the embedded device or to gain access to parts of the embedded system in order to expose other attack surfaces. Sensor attacks are manipulating or intercepting data from the sensors in the embedded system. Output attacks are manipulating the mechanical pushing-pulling devices controlled by the embedded system to bypass the controls. Processor attacks are compromising the processor directly. Cryptographic life cycle. Cryptography is art and science of transforming intelligible message to unintelligible and again transforming that message back to the original. Cryptography is the process of converting plain text into ciphered text and vice versa. Plain text is information that is in a human or machine-readable format. Encryption is the process of converting plain text into ciphertext. Ciphertext is information that is not in a human or machine-readable format. Decryption is the process converting ciphertext into plaintext. A cryptographic algorithm, or cipher, is a set of well-defined but complex mathematical instructions used to encrypt or decrypt data. Cryptographic algorithm selection depends on type of cryptology, symmetric, public key, hashing, etc., specific algorithm, EAS, RSA, SHA, etc., key length, EAS 256, RSA 2048, SHA 5122, etc., and symmetric encryption operating mode, ECB, CBC, etc. A cryptographic key is also called a crypto variable that is used to lock or unlock cryptographic functions. The longer the key, the more secure the cipher. Cryptographic methods. Cryptographic methods are symmetric cryptography and asymmetric cryptography. Symmetric cryptography. Symmetric encryption is an encryption methodology that uses a single key to encrypt, encode, and decrypt, decode, data. Symmetric encryption is also called secret key encryption. Based on the algorithm, symmetric key encryption can be categorized into two types, stream cipher and block cipher. Stream cipher is an encryption algorithm that encrypts one bit or byte of plaintext at a time. Block ciphers is an encryption algorithm that encrypts a fixed size of n bits of data, known as a block, at one time. Symmetric key algorithms are data encryption standard, DE, triple DE, 3DES, advanced encryption standard, EAS, international data encryption algorithm, IDEA, Rivest cipher, Blowfish and Toothfish. Data encryption standard, DE, is a block cipher that uses up to 56-bit keys and operates on 64-bit blocks. The 5 modes of DE are electronic code book, ECB, cipher block chaining, CBC, cipher feedback, CFB. Output feedback, OFB. Counter mode, CTR. When a ciphertext block is formed by the application of a secret key to encrypt the plain text block, it is called electronic code book, ECB. Cipher block chaining, CBC. Previous cipher block is given as input to next encryption algorithm after XOR with original plaintext block. Cipher feedback, CFB, is a mode that allows encrypted data units to be smaller than the block unit size. Output feedback, OFB, uses an internal feedback mechanism such that the same plain text block cannot create the same cipher text block. Counter mode or CTR is a simple counter-based block cipher implementation. Every time a counter-initiated value is encrypted and given as input to XOR with plaintext, which results in cipher text block. Triple day, 3DES, applies the day cipher algorithm 3 times to each data block. Advanced Encryption Standard, EAS, is a 128-bit block cipher that employs 128,192, or 256, keys. International Data Encryption Algorithm, IDEA, is a block cipher that uses 128-bit keys on 64-bit blocks. Rivest cipher, RC4, algorithm uses about 40 to 256 bits and the key sizes are different. Some of the examples where RC4 is used are in protocols such as Secure Sockets Layer, SSL, and Wireless Equivalent Privacy, WEP. Blowfish is an algorithm that uses variable key lengths of 32 to 448 bits that work on 64-bit blocks. Tugfish is a block cipher that uses 128, 192, or 256-bit keys on 128-bit blocks, and is considered to be more secure. Asymmetric cryptography. Asymmetric key cryptography uses 2 separate keys, one key to encrypt and a different key to decrypt information. These keys are known as public and private key pairs. Asymmetric key algorithms are RSA, Diffie-Hellman, El-Gamal, DSA, and elliptic curve. RSA Rivest, Shamir, and Adelman. RSA is an asymmetric key encryption algorithm named after its inventors. It uses a variable size encryption block as well as a variable size key. The algorithm uses a product of 2 large prime numbers to derive the key pairs. Diffie-Hellman method is used primarily for private key exchange over an insecure medium. El-Gamal method is based on the Diffie-Hellman key exchange. It was described by Tahir El-Gamal in 1985. El-Gamal extends the functionality of Diffie-Hellman by including encryption and digital signatures. Elliptic curve cryptography, ECC, is an algorithm that generates keys from elliptical curves. Elliptic curves are far more difficult to compute than conventional discrete logarithm problems or factoring prime numbers. Digital signature algorithm, DSA, is specified by NIST under Digital Signature Standard, DSS. This algorithm is primarily used for authentication purposes in digital signatures. Public Key Infrastructure, PKI. Public Key Infrastructure, PKI, is a set of system, software, and communication protocols required to use, manage, and control public key cryptography. Public Key Infrastructure, PKI, publishes digital certificates. Public Key Infrastructure, PKI, provides confidentiality, message integrity, authentication, and non-repudiation. Structure of Public Key Infrastructure, PKI, are certification authorities, registration authorities, certificates, certificate revocation lists, online certificate status protocol, OCSP, and cross-certification. Certification Authority and Registration Authority. Requests for certificate first go through the Registration Authority, RA, which verifies the requester's identity and registers the requester. After the requester's identity is verified, then Registration Authority RA passes the request to the Certification Authority, CA. Certification Authority CA creates and signs digital certificates, maintains the certificates, and revokes them when necessary. Certificates. A digital certificate provides credentials to prove its identity, and associates that identity with a public key. An X.509 certificate contains version, serial number, algorithm ID, issuer, validity, subject, subject public key info, public key algorithm, subject public key. Certificate life cycle. Steps of the certificate process are: certificate application, certificate application processing, certificate issuance, certificate acceptance, key pair and certificate usage, certificate renewal, certificate rekey, certificate modification, certificate revocation and suspension, end of subscription, key escrow and recovery. 4 main steps that involve a certificate issued: enrollment, verification, revocation, and renewal and modification. Enrollment is the process of requesting a certificate from the Certification Authority CA. Verification is the process whereby an application verifies that a certificate is valid. 2 types of verification methods are certificate revocation lists, CRLs, and Online Certificate Status Protocol, OCSP. Certificate Revocation List, CRL, is a list of digital certificates that a CA has revoked. Online Certificate Status Protocol, OCSP, is an Internet protocol that obtains the revocation status of an X.509 digital certificate. Revocation is the process whereby a certificate is revoked. Renewal and modification. Any certificate may be renewed if the public key has not reached the end of its validity period. PKI steps. A user requests a digital certificate, and the RA receives the request. The RA requests identifying information from the requester. After the required information is received, the RA forwards the certificate request to the CA. The CA creates a digital certificate for the requester. The requester's public key and identity information are included as part of the certificate. The user receives the certificate. Cross-certification. Cross-certification establishes trust relationships between CA so that the participating CA can rely on the other participants' digital certificates and public keys. Key management practices. Key management is the hardest part of cryptography and often the Achilles heel of an otherwise secure system. Bruce Schneier. Secure use of cryptography depends on keeping symmetric and private keys confidential. Attackers obtain or guess a secret key can compromise the confidentiality and integrity of the data protected by that key. Cryptographic key management are: secure key generation, secure key storage and use, separation of duties, dual control, and split knowledge, timely key rotation and key change, key destruction. Secure key generation. The longer the key, the more difficult it is to attack. Keys should be extremely random. Secure key storage and use. Keys must be stored securely. Major issue of key use is length of time a key is to be used, and frequency of replacement. Separation of duties, dual control, and split knowledge. Separation of duties means that certain processes should require at least 2 different individuals to complete from beginning to end. In the financial world, separation of duties ensuring that the person who has authority to write checks is not the person who reconciles the bank statements. In cryptology, separation of duties dictate that the person with access to the encryption keys does not have access to the encrypted data. Dual control means that a specific step in a process requires two or more individuals. In the financial world, dual control would be the requirement that two signatures be present on every check. In cryptology, dual control require that two or more individuals present their credentials to be able to use the key encryption key to decrypted data encryption key. Split knowledge is when a key is split into two or more pieces, requires two or more pieces be brought together to decrypt the data. For example, a box containing petty cash is secured by one combination lock and one keyed lock. One employee is given the combination to the combo lock and another employee has possession of the correct key to the keyed lock. In order to get the cash out of the box, both employees must be present at the cash box at the same time. One cannot open the box without the other. For example, a vendor might generate a large key and split it into, say multiple pieces. In this model, a minimum of n pieces are required to recreate the key encryption key. The numbers n and m are configurable so that one can, for example, split the key into a dozen pieces, but only require any three of the key holders to come together to unlock the key. Timely key rotation and key change. Keys should be rotated periodically, or based on an event. Keys should be regularly be changed. Key destruction. Keys must be properly disposed of, erased, or destroyed after its use so that the key's contents are not disclosed. Digital signatures. A digital signature is a mathematical scheme for verifying the authenticity of digital messages or documents. A digital signature provides authentication, non-repudiation, and integrity. Authentication provides recipients of a message confidence that the message originated with a specific entity. Non-repudiation provides the originator of a message with the proof of receipt of the message. Integrity is confidence the message has not been altered during transmission. Message to be signed is passed through a cryptographically secure hash function which produces a fixed length output called a message digest. This hash value is then encrypted using the message author's private key to produce a digital signature. Digital signature is transmitted as an appendix to the message. When a recipient wishes to verify the document, recipient compute the message digest for the message as received. Then they decrypt the digital signature using the author's public key to produce the originator's message digest. If the two are identical, then the recipient knows the message has not been tampered. The message has originated with the owner of the public/private key pair. Digital signature does not protect the confidentiality of the message. If confidentiality is required, the sender must encrypt the message. Digital signatures vulnerabilities are hash collision, private key disclosure, CA compromise. If the attacker can create two messages that generate the same message digest when put through a hashing algorithm is called a hash collision, then the digital signature is no longer reliable. In order for the recipient to have confidence that a message actually originated with the author, the sender's private key must remain secure, because with access to the key, an attacker can sign any message. If the certificate authority, CA, is compromised, attackers can spoof the identity of a public key and forge digital signatures. Non-repudiation. To repudiate means to deny. Non-repudiation is the assurance that someone cannot deny something. For example, Mr. X buys a cell phone for $1,000 and writes a paper check as payment, and signs the check with a pen. Later, he finds that he can't afford it, and claims that the check is a forgery. Unfortunately, the signature guarantees that only Mr. X could have signed the check, and so Mr. X's bank must pay the check. This is non-repudiation. Mr. X cannot repudiate the check. Pen and paper signatures aren't hard to forge, but digital signatures can be very hard to break. For example, you might send registered mail, so the recipient cannot deny that a letter was delivered. A legal document typically requires witnesses to signing so that the person who signs cannot deny having done so. In cryptography, non-repudiation means a document can be digitally signed and validated with a specified set of steps. After this process, both parties are sure the other can't deny that they signed the doc. Non-repudiation is accomplished by the originator signing the message using a private key known only to the originator, and which the originator commits to protecting. Protecting a private signing key means keeping it confidential and, if the key is compromised, promptly revoking the matching public key. Risk to non-repudiation is disclosure of the originator's private key. If the private key can be obtained by an attacker, then he can sign any message. To ensure digital signatures retain non-repudiation even after the compromise of the private key, one can use a trusted timestamp. Timestamp is an audit trail that provides the information on the time when the message was sent. Weaknesses in the public key infrastructure, PKI, which lead to recipients of the message being fooled into thinking a certain public key is associated with a certain entity. When attacker generated the public key and managed to spoof the identity. Another approach to non-repudiation is to use a blockchain. Blockchain is a form of a distributed ledger in which records are recorded and linked together, using cryptographic hashes, meaning that to change any record in the blockchain, one must change every subsequent block. Blockchain requires the collusion of a majority of the blockchain participants. For a sufficiently widely operated blockchain, this is infeasible. For example, Bitcoin currently has approximately 12,000 nodes across 100 countries. Hashing. Hash function provides encryption using an algorithm and no key. Plaintext message is hashed into a fixed length hash value is called a message digest or hash. It is called one-way hash functions because there is no way to reverse the encryption. If the hash of a plaintext changes, the plaintext itself has changed. Cryptographic hash functions are used to provide integrity. Common hash functions are message digest algorithm, MD5, secure hash algorithm, SHA, and hashed message authentication code, HMAC. Message digest algorithm, MD5, was designed by Ronald Rivest of MIT in 1992. Common message digest algorithm series are MD2, MD4, MD5 and MD6. MD2 produces 128-bit message digest in 16-bit blocks. MD4 produces 128-bit message digest in 5 12-bit blocks. MD5 produces 128-bit message digest in 5 12-bit blocks. MD6 produces 5 12-bit message digest in 5 12-bit blocks. Secure hash algorithm, SHA, is designed by the U.S. National Security Agency, NSA, and published by NIST. Common secure hash algorithm, SHA, are SHA-1, SHA-2, and SHA-3. Secure hash algorithm, SHA-1, produces 160-bit message digest. Secure hash algorithm, SHA-2, produces 224, 256, 384 or 512 bits message digest. Secure hash algorithm, SHA-3, produces 224, 256, 384, and 512 bits. Hash-based message authentication code is a message authentication code derived from a cryptographic hash function such as MD5 and SHA-1. Hashed message authentication code, HMAC, is a message authentication code combining a message authentication code with a hash function. Collision results when two messages produce the same digest or a message produces the same digest as a different message. Methods of cryptanalytic attacks. Cryptography is the science and art of creating secret codes. Cryptanalysis is the science and art of breaking those codes. Cryptanalytic attacks methods are: ciphertext-only attack, known plaintext attack, chosen plaintext attack, chosen ciphertext attack, linear cryptanalysis attack, differential cryptanalysis attack, brute force attack, man-in-the-middle attack, side-channel attacks, birthday attack, related key attack, meet-in-the-middle attack, replay attack. Ciphertext-only attack. Attacker knows only the ciphertext to be decoded. Known plaintext attack. Attacker knows plaintext and ciphertext both. Chosen plaintext attack. Attacker is able to submit any plaintext the attacker chooses and obtain the corresponding ciphertext. Chosen ciphertext attack. Attacker is able to submit any ciphertext and obtain the corresponding plaintext. Linear cryptanalysis was first described by Mitsuru Matsui in 1992. Linear cryptanalysis is a known plaintext attack. Involves statistical analysis of the operation of cipher to create linear equations that relate bits in the plaintext, key, and ciphertext. Differential cryptanalysis is a chosen plaintext attack that was originally developed by Eli Beham and Adi Shamir in the late 1980s. Differential cryptanalysis comparing changing plaintext with the differences between the resulting ciphertext. Brute force attack executed against a cryptographic algorithm uses all possible keys until a key is discovered that successfully decrypts the ciphertext. Side-channel attacks use physical data to break a crypto system, such as monitoring CPU cycles or power consumption used while encrypting or decrypting. Side-channel attacks artifacts are timing cache access, power consumption, electromagnetic emanations, and error information. The birthday attack is named after the birthday paradox. The name is based on fact that in a room with 23 people or more, the odds are greater than 50% that two will share the same birthday. Related key attack is that the attacker knows a relation between several keys and is given access to encryption functions with such related keys. Meet-in-the-middle attack. Attacker encrypts on one side, decrypts on the other side, and meets in the middle. Replay attack is one in which the attacker does not decrypt the message. Replay attack. Attacker is able to replay previously captured messages. Digital rights management. Digital rights management, DRM, is access control technologies that are used by hardware manufacturers, publishers, copyright holders, and individuals to limit the use of digital content. Digital rights management, DRM, uses cryptography to limit the uses by software or devices to access the DRM protected information. Digital Millennium Copyright Act, passed in 1998, makes it a crime to disseminate technology allowing users to circumvent digital rights management, DRM. Digital rights management, DRM, technologies are used to document DRM, ebook DRM, music DRM, movie DRM, and video game DRM. Document DRM. DRM to protect the security of sensitive information stored in PDF files, office productivity documents, and other formats. Commercial DRM products, such as Vitrium and FileOpen, use encryption to protect source content and then enable organizations to carefully control document rights. Common permissions restricted by document DRM solutions are: reading a file, modifying the contents of a file, removing watermarks from a file, downloading/saving a file, printing a file, taking screenshots of file content. Ebook DRM. Amazon's Kindle implement DRM to protect electronic forms of books. Music DRM. iTunes' DRM software prevented iTunes customers from using music purchased directly from iTunes on any portable music player beside iPod, the iPhone, and a few authorized cell phone models. Movie DRM. Movie industry used two main technologies are Content Scrambling System, CSS, and Advanced Access Content System, AACS. Video game DRM. Video game DRM implementations rely on proprietary consoles that use Internet connections to verify video game licenses. Digital watermarking is a form of digital rights management, DRM, technology. Secret document could be digitally watermarked so that if an unauthorized copy were made and leaked to the press, it could be analyzed to determine who leaked the copy. Invisibly digital watermarking, marking identity photographs on ID cards or passports to detect tampering. Embedding digital watermarking in documents or photographs to detect tampering. Apply security principles to site and facility design. Information security principles CIA triad, confidentiality, integrity, and availability, have been applied to site and facility design. Most important physical threat to confidentiality, integrity, and availability is unauthorized access. For example, intruders and theft. Availability can be compromised intentionally or accidentally by environmental events, infrastructure events. Environmental events are fire, floods, storms, and earthquakes. Infrastructure events are power outages, cooling failure, and floods. Locating a data center in an area of known geological stability can effectively eliminate the risk of earthquakes. Avoiding areas of known tornado and hurricane activity can reduce risk to site and facility design. Implementing administrative, technical, and physical security controls can reduce threats to site and facility design. Transfer physical risks through insurance can reduce threats to site and facility design. Contract with co-location data center hosting provider reduce threats to site and facility design. Implement site and facility security controls. Physical access controls is to ensure that only authorized individuals have access to the controlled area. Physical security controls fall into administrative controls, technical controls, and physical controls. Physical security administrative controls are policies and procedures, facility management, personnel screening and management, training awareness and procedural, maintenance and testing, emergency and incident response. Technical controls are CCTV, alarms, HVAC, utility power, fire detection and suppression, electronic access systems, and environmental monitoring. Physical controls are facility location and siting, Facility construction, fencing, and landscaping. Doors, locks, turnstiles, man-traps, lighting. Guards and dogs and ID cards. 6 layers. Layered defense in physical security are: deter, detect, delay, assess, respond, recover. CCTV cameras can serve to deter, detect, and assess. Human safety is always first priority. Wiring closets. Intermediate distribution facilities. Wiring closets. Intermediate distribution facilities must be protected from both malicious outsiders and insider threats. Wiring closets. Intermediate distribution facilities must be consider risks from flooding, overheating, or electromagnetic interference from electrical equipment. Wiring closets. Intermediate distribution facilities must be consider risks from burst or leaking pipes. Wiring closets. Intermediate distribution facilities must be consider cabling risks for telephone, alarm, and electronic door locks. Server rooms. Data centers. Do not oversecure server rooms. Data center. Server rooms. Data center security controls are: physical access, utilities, heating, ventilation, and air conditioning, environmental risks and fire risks. Server room data center security procedures are: personnel background checks, personnel training, personnel access procedures, server room data center maintenance, server room data center logging, monitoring, and alerting, server room data center control testing and auditing. Media storage facilities. Media storage facilities must ensure that the stored media do not degrade over time. Media storage facilities controls will depend on how media being stored, manufacturers' recommendations, and specific threats anticipated. Media storage facilities will be stable temperature and humidity. Media storage facilities will be air filtration and positive air pressure. Media storage facilities will be carpeting to minimize static electricity. Media storage facilities to avoid magnetic fields from electrical equipment. Media storage facilities will have procedures for tracking media. Fire detection and suppression systems need to be installed. Procedures must be enforced to sanitize and securely destroy media before disposal. Evidence storage. Evidence storage requires protecting chain of custody to prove that evidence used in court has not been tampered. Logbook records every item that has been placed in, or removed from evidence storage. Evidence storage. Room should have strict policies who is permitted access to the room. Evidence storage. Room should have CCTV monitoring. Evidence storage. Room should have double locks. Restricted and work area security. Restricted and work area security considerations are least privilege, need to know, separation of duties, dual control, defense in depth, and compliance obligations. Least privilege and need to know. Access to restricted and secure areas must be granted only to necessary for individuals to carry out their responsibilities with formally approved policies and procedures. Access to restricted and secure areas must be periodically reviewed. Access to restricted and secure areas must be auditable. Separation of duties and dual control. Restricted and work area security require more than one authenticated staff member to be present in order to obtain access to the secure work area. Defense in depth. Defense in depth designed with layers of security controls from highest security zones to low security areas. Compliance obligations. Organizations handling government or military classified data required to meet the compliance obligations. Compliance obligations requirements. Personnel identification. Guards. Electronic access control. Electronic intrusion detection. CCTV and interior access controls. Utilities heating, ventilation, and air conditioning. Heating, ventilation, and air conditioning systems should be regularly scheduled maintenance. Heating, ventilation, and air conditioning systems should be regularly testing. Heating, ventilation, and air conditioning systems should be fault detection and alerting. Heating, ventilation, and air conditioning systems should be periodic checks and audits. Environmental issues. Environmental issues considerations are storms, earthquakes, floods, tsunamis, forest fires, internal building risks, vermin, wildlife, and volcanoes. Fire prevention, detection, and suppression. Human safety is most important. Fire safety system must be designed first to protect human life. Fire needs three things to start: heat, fuel, and oxygen. Fires are categorized by the type of fuel. Class A, Class B, Class C, Class D. Class A types of fires are ordinary solid combustibles. For example, paper, wood, plastic. Class B types of fire flammable liquids and gases, for example gasoline. Class C types of fire from energized electrical equipment. Class D types of fires are from combustible metals. For example lithium metal. Fire extinguishers are based on the classes of fires they are designed to combat and the amount of extinguish. Fire extinguisher rated 5 BC may be used on Class B or C fires. 10 BC extinguisher would have twice the capacity of a 5 BC extinguisher. Using water on an electrical or gas fire can make the fire worse. Fire prevention and suppression involves reducing heat, fuel, and oxygen such that fire cannot start or be sustained. Three types of fire suppression systems are: wet pipe water sprinkler system, dry pipe water sprinkler systems, deluge water sprinkler systems. Wet pipe water sprinkler system have water in the pipes at all times. Dry pipe water sprinkler systems have no water in the supply pipes until a sprinkler head is triggered by fire. Deluge sprinkler is an alternative of the dry pipe sprinkler with open sprinkler heads. Pre-action systems are a combination of wet pipe, dry pipe, or deluge of sprinkler systems with a more sophisticated triggering mechanism.